Imagine holding an ESP32C3 in your hands with the ability to control LEDs, read buttons, or sense the environment with just a few lines of code. This lesson dives into GPIO or General Purpose Input-Output, the most fundamental interface on the ESP32C3. By the end, you will confidently configure pins as input or output, understand internal pull-ups and pull-downs, and write simple programs to control LEDs or read button presses. We'll also explore practical patterns for linking inputs to outputs, so you can build interactive IoT projects immediately. Think of this as the digital nervous system of your device, or mastering it is the first step to hands-on IoT development. The ESP32C3 Dev Kit has multiple GPIO pins, each capable of digital input, digital output, or peripheral functions like UART, I2C, SPI, PWM, and ADC. Not all pins are equal, some are reserved for boot or flash operations. It's critical to check the datasheet before using a pin to avoid conflicts or damage. GPIO pins operate at 3.3V logic levels, and exceeding this can harm the chip. Think of pins as tiny gateways, some let signals in, others send signals out, and some can do both depending on configuration. Understanding these properties helps you plan circuits safely and integrate sensors or actuators effectively. ESP IDF provides a flexible GPIO driver. The main function is GPIO_config, which lets you define pin direction, enable pull-up or pull-down resistors, and set interrupt behavior. For output pins, GPIO_set_level sets high or low states. For inputs, GPIO_get_level reads the pin voltage as digital logic. Always reset pins with GPIO_reset_pin before reconfiguring to prevent conflicts. Think of GPIO_config as assigning roles to each pin, whether it listens, speaks, or both. Experimenting with these functions in your Hello GPIO programs helps you internalize pin behavior before connecting more complex devices like sensors or relays. Let's implement a simple LED blink using an onboard LED connected to GPIO 8. First, configure the pin as an output with GPIO_config. Then, toggle the pin high and low inside a loop using GPIO_set_level with task delay to control timing. This simple exercise reinforces the workflow of build, flash, monitor, and lets you verify your development environment. Conceptually, the LED is like a lighthouse. You control when it shines and when it goes dark, giving you immediate feedback for your code changes. Now, let's read a button connected to GPIO 0. Configure it as an input with internal pull-up enable LED, so it reads high when unpressed and low when pressed. Use GPIO_get_level in a loop to detect state changes. Display messages in the serial monitor when the button is pressed. This introduces digital input handling, forming the basis for interactive devices. You can imagine the button as a sensor of intent. Your code decides how the system responds to each press, linking human action to device behavior. A simple but powerful pattern is linking a button to an LED. When the button is pressed, turn the LED on. When released, turn it off. This reinforces event-driven programming in embedded systems. You'll notice small delays and debouncing considerations. These are critical in real-world projects to prevent false triggers. By combining input and output, you start seeing how sensors, actuators, and code interact seamlessly, laying the foundation for advanced IoT behaviors like smart switches, alarms, or user interfaces. When working with GPIO, always prioritize hardware safety. Never exceed 3.3V on ESP32C3 pins, use current-limiting resistors for LEDs, and avoid floating pins. Always define pull-ups or pull-downs. Reset pins before reconfiguration and check your datasheet for pin functions. These habits prevent damage and ensure your projects are reliable. Experienced engineers treat pins as delicate interfaces. Learning to respect these limits now saves hours of debugging and prevents component failures in later, more complex projects. Now you have understood how to configure GPIO pins on the ESP32C3, write programs to control LEDs, read button inputs, and connect inputs with outputs. You've also learned about safe pin usage, internal pull-ups and pull-downs, and the basics of event-driven programming. With these foundations, you can start experimenting confidently, building small circuits, testing your code, and seeing how software directly drives hardware. These hands-on skills are the building blocks of real-world IoT applications that you'll continue to expand in the next lessons.